The bullet points for this hour are we'll go over the network needs for design, understand really what it is you have to know about a network switch as an AV design engineer. That does not mean in every case you won't need to consult with an IT engineer, but there's quite a few where I can assure you that there's plenty of applications where you can succeed with intermediate knowledge on network switches, which we'll provide you. We'll go over our network switches, as I mentioned, and how our products are designed to work out of the box. We'll go over IP addressing, subnet masks, talk about power over Ethernet, some topics you probably haven't really delved into, which is link aggregation and why it's not that scary. Fiber and CAT methods of transport. A very important one is calculating system load. This is something you may not have had to think about so much in the older days of traditional video distribution, but you do now, and again, it's not scary. And then what is multicast, unicast, and broadcast? Okay, so that's kind of the overview of what we're going to talk about. I would ask you to rudely interrupt me if you don't understand something, because it's really pointless for us to go through this and you walk away still not understanding something. So let's make sure that if you have a question that you ask it. If you don't think of a question, but later you have one, please reach out to us. Okay, so all technologies without understanding might seem a little daunting, but it's really AV over IP. It's not that difficult. I know there's a learning curve, but you have to learn HDBaseT or SDI or HDMI. You have to learn all that. So that's all we're doing, is getting an understanding of that. So there's a couple of things that really will help for you to move forward in video over IP, is to understand what's really different. There's actually a lot that's different. You're transporting signals from a source to a display for the most part. Obviously, there's other things you may do, like keyboard mouse extension or touchscreen and things like that, control extension, and we handle all of that very easily. It's good to know what it is you're doing under the hood. So in traditional switching, you're used to really just rerouting or sending SDI or HDMI, DVI, VGA. For those of you old enough to remember NTSC, PAL, transporting those, right, are interlaced signals, which is a dirty word these days, but that's what traditional switching did. In AV over IP, that's not what's happening on the network. It's transporting data packets. The signals that you're used to have been converted to these data packets, and now they have addresses on them and so on, and you're just deciding what device is accepting those data packets. So that's a big difference right there. If you were to poke into a traditional matrix switch, you could see a waveform or a vector. In packet switching, you'll see ones and zeros. All right, another difference. Traditional is basically a closed system. Even if you're converting it, SDI to HDMI and so on, you're not streaming anything. You're not sending it out over the internet to Bangkok or Morocco. None of that's happening. You may be extending over HDBaseT or fiber, but otherwise you're not actually streaming, so to speak. In AV over IP, because you've converted these signals to a network transport standard, I can send that out to the world. There's a lot of things more advanced to talk about in this, but ultimately I could send one source to almost a limitless number of people. I could literally have millions of people viewing my source. As I mentioned, extending, I've got proprietary copper CAT products, I have HDBaseT products, and fiber products. In this case, of AV over IP, extension is, as I mentioned, the sky is the limit. I can do that within a building, I could do that within a room, I could do that across buildings, and I can do it across continents. So it opens up a lot of opportunities and applications and ways of communicating that you might not otherwise have done or wanted to do. Fixed I/O. A lot of times you go out and you get an extender, one input, one output. A great example is HDBaseT, or proprietary CAT or fiber extenders. I can transmit one source to one display, or I get a distribution amp. I can transmit one source to multiple displays, but it's usually a fixed amount, a 1x4 or 1x8 or so on. Besides those, I also have switches, and I might have a 4x2 or an 8x8. So fixed switch, maybe a 1 rack unit switch or something like that. Or I might have a slot card frame where I can purchase and install cards, but usually I'm doing that in increments of 4. In most cases, there are some manufacturers that do increments of 2, but that's how I have to build up my I/O. And usually the frame isn't exactly the I/O you need. So if you need 15 inputs and 20 outputs, you have to buy a 32 by 32 frame. So that's not efficient cost per channel. In AV over IP, completely different scenario. I've got the ability to make a 1 in, 1 out extender. I can make a 1 by 73 distribution amplifier. I can make a 5 by 17 matrix switch. So you get the idea. I now can make exactly what my client needs or I need, and I can also change it. And a great example here is on the extenders application. If I have a 1 source encoder and 1 display decoder, I can connect them directly together without a network switch, or I can connect them through a network switch. So I got 2 different choices there, and one of the advantages is I can double my extension distance going through a network switch. And some of these, if you're doing something like that, just as a practical note, there are network switches that are sub $100 that will do that. And we'll talk about that when we get to network switches if I don't forget. But I can also take that 1 by 1, and what if my client or myself, I say, well, sure would be nice to add another display to that. All I have to do is get another decoder and add it. So I don't have to throw away any of the investment. I don't have to change out any gear. In the traditional types of products, I have to pull that gear and replace it. So that should lead you to realize that I could buy encoders and decoders and make many different applications work and evolve. So it's a very smart design, and it's why AV over IP is bright future because of its flexibility, expandability, serviceability. Think about if you have one channel fail on a fixed switch, an 8x8, and one channel's not working, input or output. You have to pull it. You have to unwire that whole thing, disable 8 displays, 8 sources, and that's not the case in AV over IP. You just pull whatever one piece is the issue. There's also another thing which I don't have on this slide that I will update before I send it out to everybody is Diagnostics. And actually this is very important. We've got a couple of cut sheets on this that talk about the advantages of the diagnostic capabilities of AV over IP. For example, in our 200 and 300 and T300 encoder-decoder lines, we have the ability, because the products are on the network, to capture a lot of data about those devices and underline the fact that I can also capture information about the devices connected to those boxes. I can check the complete health of the encoder and decoders over the network, but I can also detect my source math. I can check that there is a source live or not. I can determine the resolution of the source, the audio format of the source. And on the other side, on the display, I can check, is there a display active on the output of the decoder? And I can also grab the EDID table from that. And in an EDID table, I've got manufacturer's information, I've got preferred timing and all that stuff. From a system maintenance, support, management, that's very powerful. So when you look at what is it you need to identify for a AV over IP system design of the network, a lot of it is not different than traditional designs. So we're going to go ahead and list them out. But there are some things that you do have to pay attention to. The first thing is how many inputs and outputs and what kind of expansion might there be. So that's probably pretty typical in your design practice. What resolutions are required? What method of control? So when we say method of control, there's really 2 things going on here. The control of the AV distribution switching system, how are you going to control that? And what kind of control do you want to transport through the AV system? So when you look at a lot of encoders and decoders, including ours, you will find that they not just transport video and audio, but USB, RS-232, infrared. So how can you take advantage of that in your system design? How will that benefit your needs or your client's needs? So you might have a simple, maybe a bar restaurant scenario where you want to use the infrared remote control to change channels on a cable box or turn on and off displays and so on. What kind of interface? So again, common. Do you want remote control, handheld infrared remote control to control the system? We're one of the only companies that offers that. Or do you want RS-232 going to Crestron system with a touch panel, or QSYS or Savant or AMX or Extron? What control for? Who's your interface? The good news is all our stuff has a rich API. We can work with any of them. Where are sources and displays located? So this obviously would give you kind of an idea about where do I have the network switch, if you get to choose. Where are the transmitters? And they could be in the rack with the network switch. They could be at the conference table. They could be in another building. But more commonly, receivers can be distributed much farther, because displays could be outdoor displays. You could have 10 displays in a training room. So there's a lot of options. What kind of cabling are you going to use and why? And we're going to get into that. And will you need more than one network switch? And we will cover that. Who makes that network switch selection? You have to consider you may not get to choose. So you have to make sure that you're clear with the decision maker what the minimum requirements are. And we're going to tell you what that is. All right, so how many inputs and outputs? Future expansion. First of all, because you're using encoders for sources and decoders for displays, you're going to need a port on the network for each one of those. So you're going to have to keep account. And it's simple. How many transmitters, how many receivers, summit, that's how many ports you need. Other things you need to account for in network ports is a control system. It's highly likely in this age you're using a control system that communicates over the network as opposed to RS-232, so you want to account for that. System expansion. So you might want to have an understanding of 6 months, a year, 2 years from now. Is there other rooms that are going to come online? Is there additional needs? And then interlinks. So in a case where you might have more than one network switch, you need to connect them together. So you have to account for ports on that. We're going to get into that. There's a slide specifically on that. And what about other network devices? So you might have, who knows, Dante gear on there. You might have some other devices on there. So you have to account for ports for that. And you also have to account for some network switch setup that is not really that painful, but I'll talk about in a slide coming up. Resolutions, again, typical in design. Usually the highest resolution is a major factor in what hardware you select. But of course, you do have to make sure that whatever the lowest resolution, hardware will support that. It's not really as much of an issue as it might have been in the past, as in terms of sources, 480i, for example. And then any unusual resolutions. So if there's custom resolutions that you deal with, we recommend, while usually it's not an issue, it's always far better to give it a whirl in testing. And PureLink provides what we call test drive, and that's where you can bring in any of our products for a 30-day evaluation, and you can do testing like that. Okay, so let's talk about control. Again, the encoders and decoders, do they support control of other devices? We talked about the ability to transport infrared RS-232 USB across the encoders and decoders. So that's something you have to have on your checklist. As in terms of our products, I thought it would be good to provide you with some specifics here. We have 4 encoder lines currently. The VIP 100 line is what you would call follow. If you have a transmitter and a receiver, quote, connected together. The receiver is looking at a certain transmitter, video and audio. It's also allowing transport of that infrared signal. On the rest of our models, the 200, 300, and T300, you can do what you might call breakaway. Another common term that's becoming more popular is layered switching, where I can route video from a source encoder to decoder 1, and I can route the audio to decoder 2, and the USB to decoder 3, and so on. So I can split them up and route them as separate layers. The same with RS-232. And I don't mention USB here, but it's also the same in our models as layered switching for the 200s, 300s, and T300s. And then we also have CEC control available on the T300s. Okay, so in terms of LAN control, it frankly would not obviously make a whole lot of sense to, in most cases, to have anything beyond the software platform that we have. So our LAN control solution is our VPX, Video over IP Management software, which we'll touch on in a little bit. And then what kind of interface? So at this point, I'm just going to show you a web page. And on our encoders and decoders, they all provide onboard tactile control of switching. You'll see on here, especially on the T300, which is loaded with on-screen diagnostics, I can bring up an enormous amount of information as on-screen text overlaid on my display. And I have my minus plus buttons, and I can also see what broadcast channel I'm looking at. And that's true for the 300s as well, and the 100s. So your needs or your client's needs may be satisfied just with this. They don't need a Crestron system or some third-party control automation. They can just use the box. There's also an infrared control option if you want. You can plug in it depends on the model, but you can have an infrared remote control. So that's, a great solution for like bars, restaurants, or many other applications. And I don't need anything beyond that. Okay, so like I just mentioned, onboard controls, infrared remote. They may want control automation, and all our products will slip right into pretty much any control system you can name, including our own. So PureLink VPX, something to take a look at. And of course, I list a bunch of other ones here. All right, so identifying locations of sources and displays, and what that really leads to is determining cable options. So let's just cover some practical stuff. Our products come with rack mount plates. In a lot of cases, transmitters may be in the same rack as the network switch. Our receivers are designed for mounting near the display, although we do have rack plates for receivers as well. So those are easily mounted near the display. And then, of course, you have to think of outdoor displays in some cases. Really what we're addressing here is greater distances from the network switch. A key part I want to show you is, we'll go back to this T300. I have to point out, we were the first 3 years ago, greater than 3 years ago, we had been offering LAN and fiber connectivity in our encoders and decoders. So we're flattered everyone else is trying to do that now, but we have been doing that a long time. It's an either or. You can use these boxes as either copper or fiber connectivity. There's no difference in performance or functionality. It's exactly the same. You would pick based on what you need or think you should have as your transport type. And we're going to get into cables real soon here, but sometimes you use fiber even when it's a short distance, or want to use fiber when it's a short distance. And also in the case of the T300, there's a failover. It loses connectivity on one of the two connections. It will switch to the other one. All right, so getting more into CAT and fiber, as I said a moment ago, it's not always about distance. Obviously, copper is still a little less than fiber. Remember, 10 years ago, it was a lot different. Metal prices go up, and fiber is far more proliferated than it was 10 years ago, so the delta has decreased pretty dramatically over 10 years. So now it might be about your requirements of your application. The best example I can give you is military. There are requirements for fiber transport in classified transport. So copper is not even an option, no matter what the distance is. Another thing that we'll look at in a moment is what advantages fiber has over copper technically besides distance. It's immune to a lot of external artifacts that copper is subject to. When you deal with fiber, you do have to use SFP or SFP plus modules, and Those come in two different flavors for our purposes. So SFP, that acronym is commonly used when you're dealing with 1 gigabit transport speed, and SFP Plus you'll hear mostly used when you're talking about 10 gigabit. It's not actually limited to that, but to keep this simple, that's the differentiator. Now, the two different types, they both come in either multi-mode or single mode. Multi-mode is a format that can run several hundred feet, 1,800, 1,900 feet, just in that range. That's not an exact number, but just to give you an idea. And single mode is where I can run 5 kilometers, 10 kilometers, and more, depending on the module. Obviously, single mode modules are more expensive than multi-mode. In practice, we see a large amount of multi-mode modules deployed because they handle a pretty good part of the bell curve. We sell these as a complete, to provide you with a one-stop complete offering. PureLink has these, the switches, the cables, encoders, decoders. We provide everything in our catalog. They're also TAA compliant for those who do government work in the US. The T300s, most of our network switches, our SFP modules, and so on are TAA compliant. All right, so let's talk about the network switch. There's a few slides on this. First of all, we need more than one switch. It depends on a number of things. I/O port count. Do you have enough ports? That may require you to stack switches. You might have a switch on the first floor and a switch on another floor. You may need to interlink them that way. You may have a switch in a building and a switch in another building, so you get the idea. So this is where the term interlink becomes important. And we have to talk about the speeds of those ports and link aggregation. So how do we take advantage of that? Who makes the selection of the switch? We bring this up because of what I said earlier is if it's you, that's great, because by the time we're done today, you'll know what you have to have, and you can spec that. Now, obviously, we want you to buy PureLink switches, and they are 1,000% ready for video over IP. But I do want you to be very clear that these are professional grade switches that can go head to head with some of the biggest names in the network switch world, including Cisco switches, Ubiquiti, PackEdge, Extreme, Luxol, and more. These are L2 plus or L3 managed switches with a complete set of functions and features that you would expect for getting video over IP, but just to manage a data network. Please take them seriously and look at these specs on these switches. Now, you may not be the decision maker in the switch selection. The first thing is, does the existing switch support video over IP? That, as I'm sure some of you very well know, if you fail to tell the decision maker what they must have, they hold you responsible. Please make sure that you cover that liability. Let them know this is what, this is the only way this is going to work. And as in terms of new switches, if you're not the decision maker, but you're consulting on that, and they haven't bought a switch yet, then you do have at least the choice to recommend the PureLink video over IP line that is completely capable of supporting a data network. Or you'll talk about other switch brands that they may say, well, we have a requirement to buy Cisco or Extreme or Ubiquiti, and then you would just review that those switches have the right specs. And I have really good news for you when we get into what that is, because it's not a long list. Last, it is possible to mix brands and switches, and it happens often. I'm sure at least one of you has had to do that. In that case, just make sure that both of them can support video over IP minimum requirements. All right, so we're gonna dive another layer into that in a moment. Let's just make sure that we land our heads around what are the encoders and decoders actually doing. It's not complicated, like everything else that we've talked about. It's just conversion of the signal types you're so familiar with to multicast and in some cases unicast packets. All of these audio, video, USB, infrared, RS-232 become a multicast packet stream. And in the case, like I've talked about before, if I've selected the layer switching option in my encoders and decoders, I'll have separate streams going on. Understanding what multicast is, we're going to cover that. So here's one of the most important slides. What must you have in your network switch for AV over IP? So these are requirements. And we're going to look at a slide in a moment that says recommendations, which are things you should or probably do want, but you don't absolutely have to have. These items you must have. So the first one is Igmp Snooping. I have a slide that explains snooping in more detail, so you have it as a reference, but it's ultimately just an intelligent way for the switch to figure out what devices are asking for that multicast stream and making sure only the ports on the network switch that those devices are connected to are receiving that stream. So this is a form of traffic management. You certainly don't want to just blast every port on the network switch with video packets when the device doesn't want them. The first example would be your control system. It wants to talk to the encoders and decoders, but it doesn't want the video from it. Or you might have a Dante network. It doesn't need the video or really anything from these encoders in many cases, so you don't want it going to those network ports. Okay, and then jumbo frame. I have a slide on this for your reference, but it's just larger frames to handle video. For our specific VIP line, which I'm happy to talk about with anybody offline just because we won't have time in this class, is we have, like many others, intentionally gone with 1 gigabit transport methodology over 10 gigabit transport methodology. Our products require 1G network switches. They do not require 10G network switches. Only your application might. If you have so many network switches you need to hub together, then you might, but that's an application requirement. So here's a perfect example of the user interface of one of our network switches. And as you can see, it's quite loaded. Peter, I hope this also gives you some idea, and everybody else, that this is a pro-grade, full-featured product line. But I'm in specific showing the Igmp Snooping, and particularly why I'm showing you this is to convey to you how easy this is in a closed AV system to implement. This is already set up for Igmp query election and snooping. You literally just plug in your encoders and decoders, and pictures will start popping up on all the screens. So do not be afraid. We are fully aware that there are other brands that this does not happen. We know that. It's our job to know our competitors. But that is one of the major advantages. And when we're able to get to trade shows and show you this in person and live lunch and learns, we actually let people pull the cables out of the switch and plug them back in any order, anywhere they want, without any consideration for cable management, and all the pictures pop up where they're supposed to be, and switching works, control works, everything works. Please really think about what I just said, because it makes not only installation easier, but it makes your uptime much faster and any maintenance issues less stringent. Obviously in proper practice, you want to label all your cables and have some sensibility to what order things are plugged in, but our gear does not require that you do any of that. You could be the most irresponsible installer on earth and plug all this gear in and it will work. At the end of the day, that saves money, the labor line item. All right, so Igmp Snooping. This is a reference slide. Please don't read all this right now. You can read this when you go to bed tonight or whatever. Igmp Snooping, like I described earlier, is just an intelligent way of the network switch going, hey, I've got this multicast stream. What device wants it? And a receiver, a display with a decoder, is looking for broadcast channel 5. Now, by the way, we're the only ones who do that because I'm not mistaken. All of us have grown up with a cable box or a satellite box. We all know how to work a remote control, and we can pick channel 1, 2, 3, 4, 5, right? Most people don't talk about assigning or registering IP addresses. Our user interface is meant to be as simple and intuitive as possible. Igmp Snooping allows the switch to control the traffic so that those streams only go where they're asked to be. That is a very important function. All right, another reference slide. Don't read this. Multicast. There's 4 different casting modes. 2 of them have nothing to do with anything we're talking about. Broadcasting and any casting, completely irrelevant. So irrelevant that if you read it, you're kind of wasting your time. All you care about is multicast and unicast, and at the end of the day, multicast is by far the winner and what you are going to be using and need to use. What it is the ability to transport multiple data transmissions to multiple destinations. So this is why you can do 1 source or 1,000 sources to 1 display or 1,000,000 displays. Multicast is how that's happening. You may run across unicast here and there, but it can only be used in a 1-to-1, aka extender scenario. That is really all you need to know for today. All right, so multicast, that's what you're doing. All right, jumbo frame. Again, lots of data. Don't read this. Read it at bedtime. What is it? It's just a larger packet size to handle the larger requirements of video. That's it. In a network switch, like our line, they're preset. They're ready to go. There are a lot of really pro-grade switches out there that do not have this ready to go. But in most cases, you set it to 8K or higher and you're fine. And by the way, just a little troubleshooting note for you. If you don't set jumbo frame to the correct minimum value, you will have no picture. 8K is usually the bottom end. All right, let's just talk quickly about network switch port speeds. Most switches have ports that some of them might be a different speed. And a great example, I know this is very small, it's hard to see, but I show, Netgear, FS, PureLink, Cisco here. But usually when you talk about a network switch and somebody says this is a 1G switch or this is a 10G switch, that is based on the majority port. So if I have a 48 port switch that has 1G speeds on those ports and I've got 4 more ports that are 10G speeds, it is going to be marketed as a 1G switch. Power over Ethernet. All right, this is also, you see now we're into recommendations, not requirements. While our 100 and 300 and T300 series all can be run off PoE 802.3 AF, you don't have to do that. You can use local power adapters. So that's a choice. It is usually the better choice to use PoE so you don't have wall warts all over your rack and so on. And again, this is only when you're using CAT cable. Fiber cable, you can't use PoE for obvious reasons. But some really important things to note is that our products run well below the maximum requirement of the lowest power standard. PoE 802.3 AF provides a maximum power at the device of 12.95 watts. Our products are drawing anywhere from 5 to 7 watts each. That's something you think about in an installation when you have a lot of gear and you're trying to calculate BTU thermal load in your rack, HVAC, and so on. And I'm trying not to pick on anybody, but I have to. So if you look at the NVX 350 series, that uses UPoE 802.3 BT. That draws about 50 watts per device. So they're drawing almost 7 times what our product draws, which means they're generating 7 times the heat per device. They also have electromechanical fans in them. We don't. So these are all things you want to think about, in the design, not just getting something up and running, but how am I going to deal with that thermal load, and what am I going to do if a fan fails, and lots of other stuff. Also, it's more expensive. Our switches, the VIPnet series, are PoE Plus support, but of course, if you have to have UPoE, you're going to pay for that. Virtual LAN. We'll blast through this. It's really just segregating a hardware network switch into separate software-based, virtual switches. So you're breaking up the switch into separate switches. So you can completely segregate a certain set of ports from another set of ports. So you might do this where you have some data network you want to do, and then you have a video over IP network you want to do. You can do this. It's really easy. Quality of service. This is really prioritizing the data. So if you have a video over IP system and it's critical that that video does not break up or fall off or anything like that, you can prioritize your video as more important than another data on the network. So quality of service. Link aggregation is, you see our VIPnet 4804 PP-1G network switch at the bottom here. I've got 48 1G ports with PoE Plus support. But I've got 4 fiber option slots that can accept either 1G or 10G SFP or SFP Plus modules. If I need to interlink, I can use these to stack switches. At minimum, I could use 1. That would give me a 10 gigabit interlink. But what if that's not enough? And we're going to talk about that in our bandwidth calculation slide. It's right around the corner. I need more. You can, through the software, you see this screenshot of our interface on the right, there's a checkbox that says LACP enabled, and I can link 2 or more ports together to create a larger pipe. So I could take all 4 of those option slots and make them one big fat pipe. That's not difficult to do. You check the box, and that's it. See how easy all this is? All right, CAT or fiber. This is a reference slide for you. The one thing that I saved for this slide was the artifacts. Copper, in practical application, is easier to terminate. It is less expensive, and it has a distance limit, but fiber is immune to inductance, capacitance. So you could sit it next to 20 lighting dimmers, and it wouldn't know. It wouldn't matter. And I can also do higher data rates, ultimately. And again, I say or both. Yes, what I mean is I can have all my transmitters in the rack hooked up copper to the network switch, and then I could have half my displays hooked up copper, and then I might have 3 or 4 displays that are too far away, and I could hook those up fiber. Nobody will ever know but the integrator, because it'll all work the same. All right, and then this is a reference slide for your nighttime reading. For 1G systems, you're going to want to use Cat5e. For 10G systems, 6A, and you can see the bandwidth references after I send this out to you. All right, so calculating the network load. So this is the big slide. Please wake up if you're asleep. Ultimately, it's the transmitter that loads the network. Hopefully that's obvious, but let's just make sure it is. It is sending data onto the network from your source. So the data rate of the transmitter is a key value you need in your design calculations. I point out here that if you are also transporting USB, you have to factor that into your data rate. And our product manuals have charts in them that tell you how much data is going out dependent on the resolution of the signal and if you're using USB or not. That's a very valuable part of our support documentation to help you in your design calculations. Receivers aren't really doing much. They're taking in the signal, so they're ingesting the data. The only thing they do that goes out onto the network is communications. And usually when you're doing that, if you dive deep into control and you say, hey, receiver, what's your EDID table? Or do you have a source connected? Or are you on? Or what transmitter are you looking at? We're talking about bytes. It's not much at all. So it's very, very small. So you don't really need to be concerned about receivers loading the network. What is the output of the transmitter? So you have to find out what codec is this system using. So for example, our VIP 100 series uses a 264 codec. Our 200s, 300s, and T300s use JPEG 2000 codecs. Now you'll see a very large range of data rate on the JPEG 2000. The reason for that is that different manufacturers have different variants of JPEG 2000, and we choose them for, obviously, we all believe we have the right solution here. We do commonly, and this is based on 4K, by the way, so if I'm doing 1080, it could be lower, but in 4K JPEG 2000, on our 300 series, you'll probably be around 250 megabits to 450 megabits per encoder. NVX, for example, is pushing 990 megabits sometimes, but more commonly is lower. And then a lot of the 10G products out there are putting out 8 to almost 10 gigabits per channel. That's another really critical part of design. The reason why 1G encoders, decoders are so dominant over 10G encoder decoders is because I can build bigger systems with it, and it's cheaper, and we've done side-by-side live comparisons with huge audiences, and at the end of the day, I can show you a mouth-watering image on a 1G system for half the price. So what is the calculation? What's the formula? It's simple. The number of transmitters in your system times the data rate, once you look at the charts in our manuals, and then you add some headroom. That's your call. I would do anywhere from 20%. There's a lot of factors in there, but you're going to want to have some headroom. And then what other devices are adding a load to the network? And that's your number. Network switch capacity. So when we look at a network switch, and by the way, while that page is loading, we have integrators that do large stacks of switches. One that we did 5 stack switches together, so it was a pretty significant I/O. So what you want to look for is switching capacity. This number should be twice the total port bandwidth. So what I mean by that is if you have 48 1G ports, right, so that's 48 gigabits, 4 more ports at 10 gigabits, so that's 40 gigabits, so I have 88 gigabits. Multiply that by 2. That is our recommendation when you look at the specs on the switch's internal switching capacity, what it can handle. And here you see pretty much exactly what I just described. Our switch's internal capacity is twice the total capacity of all the ports combined. And then the interlink capacity. Again, this is simple math, but if I want to transport a certain amount of data streams from one switch to another, I need to make sure that that interlink covers that entire requirement. Let's see if I can just give you a quick example here. If I have a 10 gigabit interlink, and let's say I go with VIP 300 or T300 4K data rate of 250 megabits, I could do 40 transmitters between those two switches. Or maybe I want to put some headroom on that. So let's be conservative and say, the peak rate could be 450 megabits. And actually, let's put a little buffer on there. I could transport 20 sources from one switch to another. Now let's say I aggregate those together, those 4 10G ports. So I could do maybe 80 sources. I'm giving you rough examples here, by the way. Now let's say I have a 10G interlink and I'm using an SDVOE system, so I'm putting out 9.9 gigabits. I can send one source. So now you see why. And by the way, just so you know, JPEG 2000 is, all these codecs are very clever. They're very good. And at the end of the day, are you happy with the picture? The JPEG 2000 codec is used in digital cinema. And if any of you have worked in the world of digital cinema, excruciating to move from celluloid film to digital. The JPEG 2000 codec went under an enormous amount of scrutiny for years to be accepted. These codecs do a great job.